The student of class 12, this is the second video of L Hospital's theorem, question number 4.2, and the question is limit x tends to 0 e to the power 2x minus 1 over log 1 plus x. So first of all, we'll verify the form of infinity. I'll substitute x equals to 0 over here. E to the power 2x, I'll substitute 0. 2 into 0 is 0, e to the power 0 is 1. 1 minus 1 is 0 over x tends to 0. Log 1 plus 0 is log 1. The value of log 1 is also 0. Now it is in terms of 0 upon 0 form. Now given question is undefined. Now to make it defined, I'll using L Hospital's rule. To use L Hospitals, you know about these things. You have to differentiate numerator and denominator separately. The derivative e to the power 2x is e to the power 2x into 2 derivative x is 1 minus the derivative 1 is 0 divided by the derivative of log 1 plus x. It is 1 by 1 plus x into derivative 1 is 0 and derivative x is 1. Now after the derivative, the simplified quantity will be 2 e to the power 2x over 1 over 1 plus x. Now then again I'll substitute the value. X tends to 0. It is 2 into e to the power 2 into 0 is 0 over 1 over 1 plus 0. Now the answer is 2 e to the power 0 is 1 over 1. Then the answer is 2. Now the next question is question number 4.3. Limit x tends to 0, x minus sine x over log x square into sine x. First of all, I'll simplify this quantity using property of logarithm. X tends to 0, x minus sine x over log m into n. This is m, this is n. Means log m into n means log m plus log n. Now after this, limit x tends to 0, x minus sine x over 2 log x plus log sine x. We also have used the property of logarithm. Now before that, I'll verify this one. X tends to 0. If I substitute x tends to 0, 0 minus sine 0 is 0. It is 0 over x0 sine 0 log 0. Log 0 is 1. Log x is 0. Sine is also sine 0 is 0. 0 into 0. Log 0, the value of log 0 is 1. That means we are not getting the finite answer in this question. We are not getting undefined over here. 0 divided by anything is, it is equals to 0. But still I'll using L Hospital's rule in this question also. Limit x tends to 0, derivative x is 1 minus derivative sine x is cos x over 2 derivative x is log x is 1 by x plus derivative log sine x is 1 over sine x into derivative sine x is cos x. Now after simplification, now we'll get limit x tends to 0, 1 minus cos x over 2 by x plus cos x over sin x is cot x. Now again I'll substitute the limit x tends to 0. Cos 0 is 1, 1 minus 1, 0. Now we are getting over here the 2 divided by 0 is undefined. Cot 0 is tan 0 is 0, cot 0 is undefined. Something is wrong with this numerical, but the direct answer is 0 and we are getting. I'll leave this question. Something is wrong with this question. I'll do another one. Question number 5.1. Limit x tends to 0, e to the power x minus e to the power minus x minus 2x over x minus sin x. Now in this question I'll use L'Hospital's theorem. Now first of all that I'll have to verify these things, whether this is undefined or not. If I substitute x tends to 0 here, e to the power 0 is 0, e to the power 0 is 1, e to the power minus into 0 is 0, this is 1, this one is also 1, 1 get cancelled, and 2 into 0 is 0. X is 0, sign is also 0. Now it is in terms of 0 over 0 form, undefined. Using L'Hospital's rule, now we'll get limit x tends to 0, derivative e to the power x is e to the power x, and derivative x is 1, minus derivative e to the power minus x is e to the power minus x into the derivative minus x is minus 1, minus 2 derivative x is 1, over 1 minus cos x. Limit x tends to 0, e to the power x minus into this minus, it is plus e to the power minus x minus 2 over 1 minus cos x. Again I'll substitute the value. E to the power 0 is 1, e to the power 0 is 1, 1 plus 1, 2, 2 minus 2, again the numerator is 0. Over here cos 0 is 1, cos 0 is 1, 1 minus 1, 0, again we have undefined. Then using, if your answer is undefined, then again and again that you have to use L'Hospital's rule. L'Hospital's rule, limit x tends to 0, e to the power x plus e to the power minus x, and derivative minus x is minus 1, minus 0, divided by 0 minus derivative cos x is minus sin x. Now then after the simplification, we get limit x tends to 0, e to the power x minus e to the power minus x over sin x. Again I'll substitute the limit. X tends to 0, e to the power 0, 1, e to the power 0, 1, 1 minus 1, it is 0, over sin 0 is also 0, undefined. Again I'll use, using L'Hospital's rule, limit x tends to 0, derivative to the power x is e to the power x minus derivative e to the power x is e to the power minus x into minus 1, and derivative sin x is cos x. Limit x tends to 0, e to the power x plus e to the power minus x over cos x. Now we'll get the answer. X tends to 0, e to the power 0 plus e to the power minus into 0 is 0 cos 0. 1 plus 1 cos 0 is 1. 2 over 1, the answer is 2. Now another question, limit x tends to 0, sin x minus x plus 1 by 6 x cubed. Now we'll verify whether this is undefined or not. X cube is there, means definitely you have to use 3 times. Sin 0, 0, this one is 0, plus this is also 0, 0 cube is 0, this is undefined. And using L'Hospital's rule, limit x tends to 0, derivative sin x is cos x minus 1 plus 1 by 6, derivative x cube is 3x squared over derivative x cube is 3x squared, 3 2s are 6. Limit x tends to 0, it is cos x minus 1 plus 1 over 2 x squared over 3x squared. Again you will get undefined. Cos 0 is 1, 1 minus 1, 0, 0 square is 0, 0 square is 0, undefined. Using L'Hospital's rule, limit x tends to 0, derivative cos x is minus sin x, minus derivative 1 is 0, plus 1 by 2, derivative x square is 2x, again derivative x square is 2x, 3 into 2x. Now limit x tends to 0 minus sine x, 2 to get cancelled, plus x over 6x. Sine 0 is 0, x is 0 divided by 0. Again we are getting 0 over 0 using L'Hospital's rule. Limit x tends to 0. Derivative sin x is cos x and derivative of x is 1 divided by 6 into 1. Limit x tends to 0, it is minus cos x plus 1 over 6. Now then I'll substitute x tends to 0, minus cos 0 plus 1 over 6. Cos 0 is 1 plus 1 divided by 6. Cancel. It is 0 divided by 6. 0 divided by 6 is 0 and 0 is a finite answer. Dear student, this was for today's video and the remaining questions I'll solve and send it to you as a notes. Thank you.